Hello, Mr. Minnick, helping my students understand Boolean algebra as far as it relates to the ACSL competition. So here's an expression that we're supposed to simplify. Well, you can, on Boolean algebra operands, you can apply the distributive property. So I rewrite that expression using a good old-fashioned FOIL. And we have something like this. And that expression in turn, you can logically think this out if you know enough Boolean algebra. Something times itself is equal to itself. In other words, if not x is 0, 0 times 0 is still 0. If x naught simplifies to true, then a true times a true, multiplication of trues, 1 times 1 is still 1. So it's the same. Over here, this is an interesting part of it. Anything times its opposite, whether it's x, y, a, b, or c, y times y naught would always be 0, because one or the other of these two operands is going to be a 0, and 0 times anything is 0. Looking at the rest of this expression, this is something that we can factor out in x naught. So I'm going to do that. X naught factored out of that expression looks like that. Okay, rewriting everything, this plus 0 drops out, and x naught plus, well, inside the parentheses here, y naught plus y. One or the other of these two operands has got to be a true. It's got to be a 1. And anything plus 1, well, 0 plus 1 or 1 plus 0 simplifies to 1 either way. So we're left here with this middle term, or this term here, as x naught times 1. And anything times 1 is 1. So we're left with x naught plus x naught. And anything plus itself, just like anything multiplied with itself in Boolean algebra, just like in normal mathematics, that's going to be, instead of 2x naught, which doesn't mean anything in Boolean algebra, this simplifies to just plain old x naught. And that's your final answer for exercise number 1. Exercise number 2. One way to do this would be to make a table, a chart, and plug in all the possible values for the 3 operands A, B, and C. And I'm going to do that. That works on the APCS Computer Science A exam in similar kinds of multiple choice questions. So I make columns here for the variables A, B, and C. I quickly count in binary from 0 up to whatever number I get to, plugging in all the possible 1s and 0s for those 3 operands, and that's 8 possible triples. And I'm being, really sloppy here, but so first consider all 3 being false. And this is a messy expression, so I'm going to break it up into little parts. I'm just going to choose to take this part and rewrite it right here. I'm going to choose to take, say, this part right here. I'm going to rewrite this A as sort of like column number 2 over here, which is really the same thing as that column, but I'm just kind of giving it more space. And this column right here, this expression or inner expression, I'm going to rewrite here as sort of column number 3. So I just kind of like broke this up into like little parts. So real quickly, I can sort of rifle down here. A times B and the naught of that multiplication. So 0 times 0 is 0, but the naught of that's 1. 0 times 0, the naught of that's 1. 0 times 1 is 0, but the naught of that's 1. So real quickly, I can like see 1 times 1 is 1, but the naught of that is 0. Okay, A is really that column rewritten. So I'm just going to like make a note to myself that that's just a photocopy of that column right here. And now this column. I'm going to add B plus C. So B plus C is 0 right here in this first case. but the not of that union is a 1. So 0 plus 1 is 1, but the not of that's 0. So real quickly, oh look, 0 plus 0 is 0, but the not of that is 1. And here I'm back to 0, 0, and 0. So real quickly, I was able to break that little operation up into parts. Now I'm left with this column being added to the multiplication of those two. I could break this up into more little mini steps, but I can figure this out. Anytime you have a 1 plus something, the final answer, which I'm going to just put here in the star column, the final answer to where I am right now, not this final answer over here, but the final column that I'm sort of building up to this expression. So anywhere that I have a 1 in this column, I'm going to have a 1 over here. And these are all zeros, so I have a 0 plus something times 0. So it really doesn't matter what this a is, because the multiplication of something times 0 in these two cases is 0. So I'm left with zeros here. Hopefully you understand my sloppiness and you can horizontally move your eyeballs across. But now they sort of got you here because they're asking, when is this false? Not when is all of this true, when is it false? So right here is our final answer. It's false when we have these two cases. In other words, it's false when we have A being true and B being true. There are no other situations up here where A and B are both true. So when A is true and B is true, and it really doesn't matter what C is. C is a non-player here. It could be 0 or 1. So we could have 1, 1, 0 as a solution, and 1, 1, 1 as a triple, an ordered triple. Now there are other ways to get to the bottom of this. You could simplify this using Boolean algebra steps, and good luck with that if that's your poison. Sometimes it's good to make a chart like this. Okay, at number 3 down here, they just kind of gave you the problem in a different notation. We can work with that. I, myself, would quickly rewrite this as in this format here, we're using plus and multiplication operators. So this is really BA. B times A is really BA. That OR is a plus. And this is rewritten as an A times. So not B is a B with a bar over it. And then the OR is a plus. And this not C is a C with a bar. So now that I've rewritten it, I can sort of work with it easier. That's just the way I work. I'm going to rewrite that step and use the distribution there and distribute out this A across this plus. And I look at this closely and I realize I could factor out an A from all three inner expressions. And anytime you have something plus its opposite, one of those or the other is going to be a 1. And 1 plus anything is always 1. So we're left with A times 1 plus not C. And 1 plus anything is the anything. So that step, I'm just going to kind of continue over here. Whoops, I'm off the video. Sorry about that. So that A is rewritten here as A. And then 1 plus anything is really 1. And simplified, exercise 3 here on this worksheet is simply A. How about that? And I'm not sure if that's the right answer there. I'm going to pause the video. Oh my gosh, I realized I did the very first step wrong. B times A was A, but I forgot about this, no. I did that correctly. And now I realize what I did wrong here in this very last step. Sorry about that. The C doesn't just dissolve away. 1 plus not C simplifies. Well, it's me again after another break in the video. I think the answer is A. I disagree with a solution that I happen to have from the contest organizers. So if you can find an error in my thinking here where I think the answer is A, but they think the answer is A, not C, then shoot me an email or let me know, and who knows, there might be a reward for you. Okay, anyway, at any rate, moving on with exercise number 4 here on this particular worksheet. We have a long bar over the whole expression. And so immediately I'm going to apply De Morgan's law to break that long bar up. So I rewrite this as AB with a naught over it. See, this bar is being broken up, but the plus must change to an and, to a multiplication. And this bar then, there's a long bar there, there's a long bar there, there's a little, that little bar is still there, that little, and this little knot right there is still there above the B. So the plus changes to a multiplication, and the long bar is broken up into 2 bars, and these little inner bars are still there. Okay, now I can proceed, and actually I need to break up now this bar using De Morgan's law again. So that long bar breaks up into these 2 bars, but the multiplication that's there is now a plus. And you do need to keep your parentheses here. It's very important to preserve the order of operations and keep the parentheses there. Now, this bar needs to be broken up using, again, De Morgan's law. So I've got 2 knots now above the A and 2 knots above the B, but the multiplication that's in between there is now a plus, and you must add parentheses to that application of De Morgan's law. Now we still have multiplication here. Keep that in mind. Okay, now we're left with rewriting this as, we could use the distributive property. We've got FOIL. This not A times, well, these double knots kind of dissolve away into nothingness. So we have a not A times this A plus the not A times this regular old B plus this not B times this regular A and plus this not B times this plain B. And the next step here is, well, anytime you have a knot of something times its opposite, you know that one of these is going to be 0, and therefore the whole thing cancels out to that false. 0 is false, you know. And similarly, that's going to be a false. So we're left with these 2 guys right here. So rewriting it real quickly. And this is kind of like, there's an identity that probably speaks to this, but you could just think it out. We want to know for what ordered expressions this is true. Well, between A and B, you only have these options right here. And anytime that A is false, then this whole term is going to be 0. And this part of the term, the false A, is really a 1, and you're left with whatever B is. And so this right here is the only, of these 2 ordered pairs, this is the only solution that would make it true. And sort of like, look, these are opposites. So I'm just going to go with the sort of the opposite pattern for these 2, where B is the determiner, and there's your solution. Now we could have also made a chart like we did up here in this problem, and that would be a good way to attack number 4, to use one of these charts. But I sort of did it a different way. So our solution there is these 2 ordered pairs make this original expression true. And finally, number 5, this is just a lot of algebraic manipulation here. We use the distributive property across these different little expressions, or whatever property it is that, yeah, distributive property, I guess. So I'm rewriting this by dissolving the parentheses. Now that b times b is really just one copy of the b. And I could rearrange this with commutativity, or I could just talk about doing it if I were in the interest of time here. Let me pause the video and think about it. Okay, I did some thinking, and you know what? I'm just going to rewrite it and use to factor some things out. So rewriting this one more time. I'm just going to pull out some common terms. This b could be factored out here from these two parts, leaving a 1 right here. And sort of like, you know, that's all of this just kind of like turned into that. And anything plus 1 is simplifies to a 1. So that whole thing is really b times 1, which is really b. Here I can factor an a out. I think that would be productive because we end up with a c plus a not c. And anytime you have something plus its opposite, you know that one of those is going to be a 1, and therefore a 1 plus 0 simplifies to a 1. So I'm left with a. So sort of all of that changed into just plain old a. And this term here, the not b term, I'm just going to rewrite. This term I'm going to rewrite down here. It's a little messy. So you know what? I'm going to rewrite everything up here in a nice, neat manner. Still moving forward, I can factor an a term out of these two inner parts. So I'm left with a b naught plus now a 1. And anything plus 1 is 1. And I can factor a b out of these two terms. I could also rearrange them. So I'm left with b, 1 plus c, plus the a is I just shifted it over. 1 plus anything is 1. And so I'm left with simply b plus a. And I would like to write it in the form where alphabetically a is before b in the alphabet. So that's the way I'm going to express it as my final simplification. Have a good day.